Penstock Phase 2. That was again from essentially from third crossing down to the treatment plant. Again, another set of challenges. There were some areas that were quite hard rock and some productivity challenges with the trenching there.
Well, the first day that we started, just out here behind the treatment plant, we hit a lot of rock back there, so we weren't sure how fast we were going to be moving along putting that pipe in. We were a little concerned with what we saw, the results of the trencher going through the rock in that area. There's a few issues with dialing in the trenching machine, the rock saw that they had. They were going through teeth very fast, and they had a couple issues with the machine breaking down, so that contributed to the initial delays that we had.
And then they got out of that same Tapete sandstone and got more into some just loose rocks and heavy clay and stuff they could dig, and then occasionally encountering the tougher rock where they had to hammer it out until they got to a section that they had pre-dug and knew it was a lot of feet of solid rock.
What they were trying to do is when they hit a soft area, they would move the trencher up to the harder rock area where they needed the trencher. There were some spots in between that were soft, and they could excavate that conventionally, and so they would jump ahead with the trencher and hit the hard rock areas.
Everybody knew you were going to hit hard rock.
We expected there to be rock, but the different types of rock we did not expect.
Because some days you could cut through it with the trencher, and other days you'd get stuck and maybe do 80 feet.
We did encounter a lot of different rock.
The question is how you were going to get through it.
In some places, the machines that we were using were too small and just not capable of doing the job, so then we had to switch to doing some blasting as well.
At second crossing, when the contractor was trying to excavate for the pipeline, they really encountered rock that was extremely hard, difficult to mechanically excavate through, and decided to really employ drill and shoot blasting techniques. And so they developed a drill pattern, drilled the holes, loaded with explosives, shot the rock.
Burn the hole!
But even after they drilled and shot, some of the blasted rock was still too large to really handle. And they ended up with a track-mounted hoe ram going in and breaking that up to some smaller fragmentation sizes. They were careful in that they didn't want to use too much explosives. So even though that was a little more difficult for the contractor from a production standpoint, it was really a function of them being prudent and not overshooting it.
We looked at a couple different areas where we could have shortcutted it a little bit, but it involved cutting through a lot of rock, like up at what we call Cell Point, which is just south of Second Crossing. We were thinking about cutting through there at one point. Somebody had an idea that maybe if we tunneled through that mountain there, we'd save some time, but they did some potholing and testing and found out that that was a lot of rock to be tunneling through, and there was no guarantees on the cost involved with trying to do a bore that size.
Obviously, the reason that the pipeline is in the place it is the same reason that the adjacent Houston Mesa Road has been there for 120 years, is that that's the path of least resistance through the mountains. It happened to accommodate our needs by staying basically in the ditch alongside that existing 120-year-old road. We just minimized to the very minimum the impact on the National Forest resources. They'd already been disturbed for 120 years.
There was a lot of work that went into having wildlife biologists and archaeologists and all sorts of natural resource specialists look at the pathway of that pipeline and make sure that where we were putting it made sense in the scope of all the other resources that we manage. So absolutely every project that we're looking at requires us to consider how that's going to impact the other resources and other uses of the Tonto National Forest. We have a requirement through the state of Arizona with the State Historic Preservation Officer to ensure that any ground disturbing work we're doing is mindful of the cultural resources on the ground.
The Forest Service had the foresight to know that the sites they asked us to avoid were significant archaeological sites. So we consider that very helpful.
That section had some archaeological resources that needed to be avoided.
It was the remnants of a prehistoric human occupation. And so it's difficult to get those kinds of sites back when we lose them, and that was the importance in this situation. We asked that they move the pipeline over to the other side of the road and back again.
Contractor avoided the archaeological resources as required.
I think the environmental challenges and the coordination with the different federal agencies were at least equal to the engineering challenges on the project. I really do. The river crossings were challenging.
The crossings were a challenge only because of the time of year we had to do them when the water was at its low point, and so we had to remob to go back and do those in the middle of doing everything else. That was probably the biggest challenge, trying to be environmentally friendly in the crossings, because they are very sensitive.
We had to do crossings at a certain time of year during low water so that we didn't have a lot of water flowing, and we had a window given to us by the federal government. Said we could do it at these times of the year, and those are the only times of the year.
Conventionally, when you lay any type of pipeline, you like to start at the bottom and lay uphill. We did it the opposite because of the need to work around the availability of the different kinds of pipe, whether it was here or not, manufactured and delivered here or not, the equipment available to lay the particular kind of pipe, the manpower available. So it wasn't always what we wanted to do or the contractor wanted to do, it was circumstances influenced by outside entities.
Most folks think that the project is linear, and you start at point A and you go to point Z. In this particular case, they did some of that. Availability of the materials was an issue, that they had to wait for the pipe to actually be constructed to meet the elevations and the profile of the road, because this is laid adjacent to the road.
Ductile iron pipe is a great pipe for this application because it's very durable, particularly in hard rock country like this. But when you get above about 350 psi water pressure on it, they don't make pipe where the rubber gasketed joints will withstand that pressure. So that's when you transition to welded steel pipe. And of course it's more expensive pipe, it's slower because they got to weld the joints, but that'll take you up past the 450 psi mark.
Your steel pipe is bell and spigot, which requires you to close the joint by welding and using non-destructive testing to accept the weld, which has to be done on every joint for every 40 feet, which takes a while.
The standard routine for welded steel pipeline is constructed on top of the ground and what they call roll it, which you take at least 3 side booms, and pick it up at varying lengths and just lay it down in the trench, and it'll sure enough, even at 18 inch or 36 inch, will take that bend and roll into the trench.
That's one of the nice things about spirally welded steel pipe. It's more like a slinky because you use coil steel that's anywhere from 36 to 48 inches wide, and it's welded on a spiral, which gives it a lot of flexibility. It's not rigid can pipe with square seams. It's spirally welded. It was a lot easier to weld them at the side of the road when we shut down the lane of traffic and let them work at the side of the road with fire watch so that they didn't start any fires, and then just lift up that section of pipe with the track hose and drop it in and then do a closure weld.
Oh, overall, I think it was a very, very successful job. As it ends up, everything testing out really well. We tested the whole line with less than a half a truckload of water, which is really good. That's pretty well unheard of.
From Forest Service perspective, the reclamation of the pipeline in that we were reclaiming the areas that were disturbed in a way to make them look as natural as possible turned out really well. We again reclaimed boulders and placed them sort of partially buried to make them look more natural, and the contractor did a good job at that. And we used a native seed mix, and actually when I look at that now, the seeding has really done very well, and you can hardly tell where the pipeline was. So we're very pleased overall with how the penstock turned out.